Hello and welcome to section 2.5. In this video we're going to be doing the examples 1, 2, 3, and 4. First doing a quick review of these different forms of equations, of linear equations. And this is mostly going to be about modeling, which means real life sorts of examples, so word problems using linear functions. And an important note about these example videos, these are going to go a little bit faster than it would normally go in class. So that is good if you can hang with a fast speed, but if you need to pause it to write stuff down, then do so. If you need to pause it to go back and review section 2.1 or 2.3 or 2.4 to review some stuff, if something's not making sense, it might be because you forgot about something back then and you might need to review that a little bit. That's okay. So take as much time with these videos as you need. It's designed to be sort of flexible that way. This is a plus of doing things online. But you have to be on top of your own understanding. So anyways, with that in mind, let's look at these different forms of linear equations. So something that these all have in common is that they're all describing y and x are the variable, but everything else that I'm highlighting here is some specific number. The b and the m and the y0 and the x0 and the a and the b and the c, those are all some specific number. The y and the x are the variables. So for any particular equation, a and b and c, or b and m, or everything highlighted in yellow here, that's always going to be a particular specific number, but the y and x would remain as variables for that equation. Okay, so slope-intercept form, this tells you the slope of it, how much y increases, this whole thing increases here every time x increases by 1. So every time x goes up by 1, it's going to go up by m. And the y-intercept is b. That's what you get when you plug in x equals 0. So you could also say the y-intercept is the point 0, b. So with point slope form, the slope is m, because still if you're going to distribute that m in there, you would still get m times x. So the slope is still m, but then if you plug in x equals x0, that makes this whole thing become 0, and the result for y would then be y0. So that means it has the point x0, y0. And then for standard form, we haven't talked about this as much, but it is useful for describing certain situations that we're going to see here. Okay, so for example 1, we have the monthly cost of a certain Google Fi wireless data plan is $17 plus $10 per gigabyte of data. Let's write a formula for C, the monthly cost, when you use D gigabytes of data. So with this kind of thing, it helps to write a table using the values, using the information that it gives you. So it's going to be a formula for C. So C is going to be like the output. D is going to be the input. Let's think about, what if you use 0 gigabytes of data? Or what if you use 1 gigabyte of data? Or what if you use 2 gigabytes of data? What is the cost there? So if you use 0 gigabytes of data, and by the way, I am going kind of fast here. If you need to pause it and to read this more carefully, that's probably a good idea. So I'm assuming that everybody understands this right now, and I'm just going to keep going. So if you use 0 gigabytes of data, the cost is just going to be $17. So that would just be, $17 right here. If you use 1 gigabyte of data, then that's going to be the $17 plus the $10 for that 1 gigabyte of data. So this would be 17 plus 10, which is 27. If you use 2 gigabytes of data, then this is going to be, well, there's still the $17 plus 2 gigabytes of data is going to cost $20, or 2 times 10. So this comes out to be 17 plus 20, which is 37. Okay, so in general, what's the formula going to be? The formula for C is going to be, well, what are we doing with the D to get the 17 and the 27 and the 37? Well, we're starting at 17, and every time D goes up by 1 gigabyte, the cost goes up by $10. So that's the slope, is 10. All right, so that's the formula for that. Now, let's look at example 2. A roofer charges $7,000 to replace a 500 square foot roof. And then, for every additional square foot over 500, they charge $6 more. Let's write a formula again for C, the cost of replacing an A square foot roof. There's a little typo here. The's not supposed to be there. So let's see. Again, let's make a little table. Let's look at various costs. Or sorry, various costs for various square feet of roofs that you might have. So if the area of the roof, if the A is equal to 500 here, then what is the C? It says they're going to charge $7,000. So that means it costs $7,000. Now, what if you have an additional square foot over 500? So what if it's 501 square feet? Then the cost is going to be $6 more than 7,000. So 7,006. What if it's 502 square feet? Then the cost is going to be another $6. So 7,012. Okay, so this is a situation where we know how much the C goes up every time the area of the roof goes up by 1. That's the slope. So it's $12 per square foot. And we also know a particular point, like the A0, C0 here is the 500, 700. So that means we can write this in point slope form because we know a point and we know the slope. So looking at point slope form here, I'm going to write this just with, it's a formula for C, so we're going to have C instead of Y, and we're plugging in the variable A. So I'm going to write this using A and C. So that's going to be C equals the C0 plus M times A minus A0. And in this case, the C0 is 700. That's like the starting cost. Plus the rate of change here is 12. The slope is 12 times, oh, sorry, that's 7,000. Whoops. I don't know why I said 700 there. Just checking if you're paying attention. Okay. Plus 12 times A minus A0, which gives you A minus 500. So if you want to check that this works, a good thing to do is make sure it works for the information that they tell you. So if you plug in A equals 500, this is a good thing to do yourself. Plug in A equals 500 into this and make sure the result is 7,000. Try plugging in A equals 501 and make sure the result is 7,006. So I definitely recommend pausing it to make sure that this formula works with the table. Okay, so for example 3, we have the situation where there's $20 to spend on fruit for your family for the week. Trying to only go to the grocery store once a week so that you're social distancing because of coronavirus. Okay, so apples cost $1.50 a pound and bananas cost 40 cents per pound. Let's write an equation about A and B, the amounts of apples and bananas you can buy. Okay, so if A is the number of pounds of bananas. So if you buy A pounds, wait, did I say bananas? I meant apples. The cost of 8 pounds of apples is going to be, well, if A equals 1, the cost would be $1.50. If A equals 2 pounds, it would be 2 times $1.50, or $3. So in general, the cost of 8 pounds of apples is going to be 1.5 times A. And likewise, the cost of B pounds of bananas is going to be 40 cents times the number of pounds, so 0.4 times B. So the total cost is going to be 1.5. My computer's being a little weird. 1.5 times A plus 0.4 times B. But there's another way we can write the total cost. It says you have $20 to spend on fruit, so the total cost is also $20. So you can write it both ways. And if you're spending $20 on apples and bananas, then there you go. That is your equation relating apples and bananas. Okay, so that's how to approach these. So this is an example of each of the 3 different kinds of forms. We've got slope-intercept form here. The 17 is the intercept. The 10 is the slope. Here we have point-slope form. And the slope, of course is 12. So that's point-slope form here. And this one is standard form. So standard form is useful in situations like this where we have what's called a constraint equation. The constraint equation tells you like something about the total value of A and B in this situation. Okay. Now let's look at example 4. Could the table represent a linear function? And let's give a formula for the linear function if it could. So the hallmark, basically the definition of a linear function is that it has constant rate of change. So in other words, the change in y divided by the change in x is constant, meaning no matter what 2 points you get, if you find the change in x and the change in y, when you divide those to get the slope, it should always be the same. That's what it means to be like a straight line. If the slope was changing, you'd have like one slope over here and a different slope over here, and those slopes would be different numbers. So that's not linear. All right, so let's look at this. Here, I'm going to make a little row of delta x's here. From 0 to 5, the change in x is, if you go from 0 to 5, it changes by 5. So that's 5. If you go from 5 to 10, it's increasing by 5. If you go from 10 to 15, it's 5. If you go from 15 to 20, it's 5. If you go from 20 to 25, it's going up by 5. So the change in x here is always 5. And let's look at the change in y. We're going from 200 to 180, well, it's going down by 20. So the change in y is negative 20. When you go from 180 to 160, it's also going down by 20. Going down by 20 again, and that's true for each of these. So in this case, for A, the change in y over the change in x, it's going to be, let's see, negative 20 over 5. The other one is going to be negative 20 over 5. And what we want to see is this always the same? And in this case, yeah, it is. Negative 20 over 5 is equal to negative 20 over 5 is equal to negative 20 over 5 is equal to negative 20 over 5. So it's always negative 20 over 5 is just negative 4. So it is linear. So if it is linear, then the equation we could use would be slope-intercept form, because in this case we know the intercept. You could also use point-slope form with any of these 6 different points we have here, but 0, 200 is the intercept, so you might as well use that. So that would make the equation y equals 200 minus 4x. Okay, so let's go over B here. I'm going to do the same thing. I'm going to get the change in y between each of these points. Here the change, and the change in x. Here the change in x is 5. When you go from 5 to 15, that is 10. So that's a different change in x there. Here the change in x is 5. Here it's 5 again, and here it's 10. Okay, so then here it's negative 20, and actually it looks like it's going to be negative 20 everywhere. Okay, so sometimes from like this point to this point, you'll have negative 20 over 5, but then is that equal to, over here we have negative 20 over 10. Well, negative 20 over 5 is negative 4, and negative 20 over 10 is negative 2. So that means there's a different slope from here to here between these 2 points, which is negative 4, and then from these points you get negative 2, so that's a different slope, so it's not linear. Okay, so alright, so next you have some exercises to do. Exercise 1 is pretty similar to what I just did. Exercise 2 is kind of tricky. Exercise 3 is really tricky. There's also a typo here to fix. So in the next video, I'm going to go over those answers, but it's important to try these on your own first.